how it propagates. So starting with sound and how energy
So, so,
transfers. So what is a sound wave? How can you describe a sound wave? I've,
so a
you,
sound wave
yes, you
is
know,
so sound wave can be like sort of not reflected, but they bounce back from any surface.
yeah, that's very correct. They get bounced back. That's one of the property of a sound wave. But how can you define a sound wave?
So sound wave is something which um, transfers.
See, the first thing is sound is a mechanical wave which is produced by the vibration of the particles of the given medium. So we write sound is a longitudinal wave that is produced particles of the medium.
Okay.
Okay, so last time I've told you how longitudinal waves propagate. You tell me how they propagate.
So they extend and then they contract.
Yes, and they have a particular name for this. I told you the particular name when they come closer to each other and when they moves away from each other. What that process known as?
So um so when that compression,
Yes.
then rarefaction.
Yes. So sound waves travel through compression and rarefaction. That's very correct. Okay.
Yeah.
So
So with your definition, what is the like meaning of medium in this context?
okay. And so, like you're saying, what a sound is a longitudinal wave that is produced by vibration of the particles of medium, which means suppose this is air. So these are the air particles. Okay,
Mm.
and this is my mouth. If I speak, so what's happening when I speak? My mouth is vibrating. When you speak, you can sense a vibration on your teeth and on your gums. You can feel that sensation because actually we are vibrating. That larynx, that a voice box inside our throat, that vibrates because of that sound produces. So when our mouth vibrates, so the air around our mouth, if I open my mouth, there are a lot of air particles inside my mouth, outside my mouth. So the air particles that are adjacent or that are around my mouth also starts to vibrate. Suppose if I'm vibrating, or if you touch a vibrating phone, your hand also starts vibrating because vibration transfers from your phone to your body. Same thing happens here. If your mouth is vibrating, then this vibration is transferred to the vibration of the particles of air, because air is made up of small particles, right? Small particles of oxygen, small particles of hydrogen. So that is the air. So when my mouth vibrates, these particles near my mouth also starts to vibrate, and they keep on transferring energy one by one, which means if this particle is vibrating, this vibration is transferred to this particle, then this vibration is transferred to the adjacent particle, and in this way the tra- like this transfer the vibration to this particle then transfer vibration to this particle. So in this way it keeps on transferring the energy in the form of vibration. Okay, they are transferring energy, but how? By vibrating. Okay, there are a lot of ways of transferring energy, but in this case the molecules of air are transferring energy by vibration, that is by moving up and down, left and right, like this. Okay, and it reaches until someone hears your sound. Is this clear?
Yeah.
Can you just explain me?
Yeah.
Okay. So tell me how
So
sound wave travel.
because you can only draw that 2D, will the vibration spread with 180-degree diameter?
Sorry?
So can the sound spread?
Sound spread, yes, definitely. It has a magnitude. That means it's not necessary that only this particle. Vibration can be transferred to this part also, to this part also. Wherever like there are air particles, it transfers. So that's why sound can travel to all the sides. If there's a speaker, you're listening sound, so you can hear that sound from every room, right? Because it travels in every area. So wherever there are adjacent particles, it can transfer the vibration. Okay.
Okay.
Okay, now explain. You can explain a sound wave, how it travels in a given medium.
So a sound wave is vibrations is is vibration produced. So a sound wave is nothing but a longitudinal wave, and it is produced by vibrations of particles to air.
Yes, yes. Continue. How sound wave
Is-
travels.
So it travels with rarefaction and compression,
Yes.
as well as not only going straight but spreading as well.
Yeah, definitely. Okay. Now, second is that it's you tell me because sound travels when the particles of a given medium vibrates. Can sound travel in a vacuum?
No,
Yes, because vacuum has nothing. There are no particles, and if there are no particles, there will be no vibration. No vibration, no transfer of energy, no wave movement, no sound produced. Okay? So in vacuum, I'm writing it here. No particles. There's nothing in there. No particle. So there will be no vibration. If there are no particles, then no vibration. No vibration of particles. Since there are no particles there. And if there's no vibration of particle, that means no energy transfer. No energy transfer, that means no sound produced.
okay,
Okay? So you take the screenshot of this, then I'll move on to the next one.
okay, okay. Yeah, I've taken.
Okay. Now, how fast does sound travel in given medium? Which means basically there are three forms. It's we have seen that in vacuum it can't travel, but now on Earth if we see, So it's solid. Now actually the sound travels because of the vibration, right? So vibration is that if
So
we
vibration,
is it
yeah,
that means it keeps
travels.
on, yeah, vibration, which means it keeps on transferring energy. If one molecule vibrates, then it transfers energy to the next molecule, then to next molecule, and in the same process it keeps on transferring energy until it reaches to the last molecule. If we see the structure of a solid, so the molecules are closely and tightly packed to each other. Okay, this is the structure of a solid, and they are in a regular pattern. Now for liquid, there is some gap and they are randomly arranged. And for gases, the molecules are quite away from each other. Like if there's one molecule, second will be here, third will be here. Okay. Now if we see the movement of the sound wave, it's like if one particle vibrates, it's transfer its energy to the next molecule. Then this molecule starts to vibrate, and because of the vibration, it transfers its energy to this molecule, and this also starts to vibrate, and it keeps on doing this until it reaches to the last one. Okay. Another thing is, if someone is quite closer to you, you can easily pass something. Suppose if there's an analogy, two persons are standing close to each other. In this case, the person are at this distance, and in the third case, the two person are this. They have to pass a ball. In this case, this person passes the ball to this person. In this case, this person passes the ball to this person, and in this case, it passes the ball to this person. Now you tell me in which case the ball will take the shortest time to reach to the second person. Tell me.
A solid.
Yes. In this case. In this case, the ball will take the shortest time. That means here the sound will travel faster, right?
Okay.
Because vibration transfers very quickly. So within a second it reaches up there. Since the particles are comparatively away from each other, so it will take a little longer time to reach the vibration from this point to this point. And since they are quite far away from each other, that's why it will take much larger time to transfer its vibration from this point to this point. And that's why sound travel fastest in solid. Is this point clear why sound travels fastest in solid?
Yeah. But some solids can be really thick, so the particles can be really dense. Sound will not be able to pass through.
No, no, whether they are denser, but still they are closely packed with each other. And it doesn't matter if they are densely packed with each other, which means actually the more denser the object, the faster it will actually transfer the energy. Because if the particles are quite close to each other, they can easily transfer their vibration.
Can
Okay,
you draw an arrow with sound travels faster to the solid?
okay. So yeah, so it's just like this. These are the molecules of solid. That means quite closer to each other. They are tightly packed with each other. Okay. So when sound travels, suppose it's from here. Sound is what? It's a form of energy. It's simple. So when energy is transferred to the first molecule, it starts to vibrate.
Okay.
Since they are quite close to each other, there is no distance in between these two particles. So it quickly transfers its vibration to second particle. quickly transfer vibration to nearest particle. As soon as this particle gains energy, starts to vibrate, it quickly transfers its vibration to this molecule. Now here vibration is then transferred. Then quickly the vibration is transferred to this, because they are just closely packed with each other. It's very clear, if the current is flowing and if you touch it, you immediately gets electrocuted. Why? Because you are in touch with that. Same as they are in touch with each other, that's why the vibration is passed very quickly and sound travels very quickly. And that's why sound travels fastest in solids. Is this clear?
Yeah.
And since in liquids there is a gap, so it will take a little longer time, which means when this particle vibrates, it has to move from this point to this point. It has to walk some distance to transfer its vibration, right? Then after gaining that vibration, this molecule has to move and reach to this particle. Then this molecule will move and has to reach to this particle. So in moving in between, that gap will take a longer time. Okay? And same as in gas, they are quite away from each other, so when it gets vibrated, this particle has to move all the way from there to there in order to transfer vibration. So it will take more longer time. Is this clear?
Yeah.
And that's why the sound travel slowest in gas. So the order of sound travel is sound travel fastest in solid, then in liquid, and then in gas. Okay? Okay, now you explain this to me.
So, after the three states of matter, sound travels faster in solid because the as the particles are tightly packed in, sound is able to move through the vibrations around the one point in a solid.
Yes, because there is no gap between the particles, they can easily transfer their vibration from one part to another part. So sound travels very quickly in the solid. Okay.
Okay.
Now in liquid, how it travels?
In liquid, um, it travels quite slow
Why?
because the particles are spread out and they're also not real, they're randomly arranged.
Yes, and there is a gap between the particles of solids, right? There is a gap. So it has to move, that particular particle has to move all the way to transfer its vibration to the adjacent molecule. Suppose you're sitting with someone who is very closer to each other, you can easily pass a pen. But suppose if there is someone who is in another room, you have to take a pen, move, walk all the way to the room and give the pen to him. So definitely this will take much larger time, longer time as compared to the one if someone is quite closer to you. Same thing happens here, because in solid particles are very close to each other, so you can particles can easily transfer their vibration. But in liquid there is a gap. Okay, one particle is here, another particle is there, so the particle has to move. When it carries energy, it has to move, it has to walk some distance and then transfer its energy to the adjacent molecule. So this walk in between the spaces takes the time, and that's why sound travels little longer in case of liquids. Okay,
Okay.
it will take longer time as compared to the solids. And how sound travels in gas?
How sound travels. Wait, the unit.
No, no, process, how it travels in gas, why it takes larger time when it travels
Oh,
in air.
because they're like they're spread out in such a way that it's almost nearly impossible to, for sound to travel in gas.
No, no. The distance between the molecules are larger. Okay? So I'm writing here. You take the screenshot, then I'll move on to the next slide.
Yeah,
Have you taken it?
yeah.
In gases, molecules are a greater distance. So a molecule or a particle takes larger time to transfer vibration. Energies of vibration. Okay?
Okay.
That's why sound travels slowest in air. Now, since we are talking about the motion or the propagation of sound, that in which medium it travels faster or slower, so now let me see the speed of sound. The general speed of sound in air is 330 meters per second. So speed of sound in air. Clear?
Yeah.
Okay. And now the speed of light in air or in vacuum actually is this. Okay. That means if you see it, 30 crores, or you can say 30 million meters per second. Okay,
Okay.
that's the speed of light. Now you don't have to learn this as of now. This is important. But if the question is why we hear the thunderstorm, like if there is a lightning, you can hear that lightning, that sound. Okay, so
Sound so sound will be there first when lightning happens second.
no, no, we see the lightning first, then we hear the sound. Why?
Yeah, so we see the light first and
Yes.
then the sound.
Yes. Why? Because light travels faster. This thing happens simultaneously, which means when we see the lightning at the same time, sound is produced. But the problem is that light travels very much faster. So we can quickly see that, but sound travels slower. So after some minute we can hear, like after a few seconds we hear that sound. Okay,
Okay.
they are produced at the same time, but because of the motion or because of the speed of light and sound, there is a difference of that, because light travels
Yeah.
faster so we can see, sound travels slower, and that's why we hear it after some time. So
Okay.
this is about the propagation of sound. So now a quick revision. You tell me, what kind of wave is a sound wave?
Longitudinal wave.
Yes.
It moves in a way with um, compression and rarefaction.
Yes, that's very correct. Okay, and first tell me, what is the structure of solid, liquid and gas?
So a solid is um, the particles are really tightly packed, and the difference between the liquid and gas is the liquid is slightly um, apart, and they have space to move around them, and they're randomly arranged, as well as the gas. They're all over the place, and they're not in any particular order.
Yeah. And for gas, like gas, you haven't explained correctly. Gas is that there's a larger distance between the molecules. Okay, can you see this structure? They are quite
Yeah.
away from each other as compared to the liquids. Solid are tightly packed with each other, the molecules. Liquids are relatively away from each other, and gaseous molecules are far away from each other. Okay. Now tell me how sound propagates in all these three mediums.
So sound
Yes.
is nothing but a longitudinal wave. So it will compress, then so it'll transfer its energy through vibrations. So
Yes.
in the air.
But how it travels in all these three mediums? Definitely it's a longitudinal wave and keeps on moving by compressing.
So it'll move from one vibration to another. So one particle to another, to another, to another.
Yeah, that's the propagation. But why it moves fastest in solid and slowest in liquid?
Because the particle bonds are really tight and they're really compact, so it's able to do it very quickly. Whereas the liquid it's more slow, and the gas it's very very slow.
Yes, because the molecules are very, very far away from each other. So you can see I've written in gaseous molecules. In gases, molecules are at a greater distance, and a
Yeah.
molecule or particle takes longer time to transfer energy and vibration, because if they are at larger distance, so one particle has to move all the way to transfer the vibration to the adjacent particle, right? So that's why in this process it takes a longer time as compared to solid. Okay, is
Yeah.
this clear?
Yeah. Let me just screenshot this.
Yes, you take the screenshot.
Yeah, I have taken it now.
Okay. So this is about the sound and energy transfer. The next is loudness and pitch.
Okay.
Okay. Now, in order to understand the loudness and pitch, we should know the amplitude and what? The frequency. So we start with the amplitude. So again, you tell me what's the definition of amplitude.
So amplitude is the distance between the two peaks.
I poured all susu on the cake.
Okay, so
Wife tells it.
yeah,
Every
so
day,
so
everywhere
the
I put susu
amplitude.
will come. It's just there. Don't go and say.
Well, wait.
I'm not.
You tell me why.
Because everything back there.
Uh-huh.
It is all susu.
No, it is not susu. It is I
Yes,
wiped
then
it.
what is amplitude? Amplitude is
I,
not the distance between two peaks.
I don't have
It's
that. I
wavelength.
did your.
Yeah, the
I wiped
wavelength.
it.
What is amplitude?
Amplitude is the
Tell me.
amplitude is the largest displacement from the distance between the peak and rest
It's
position.
the largest displacement from the rest position to the peak.
Yeah.
Okay. Yes. So if I draw this wave, tell me what is amplitude here.
Amplitude.
Yes. Here you just have to mark this. Tell me where is amplitude.
Yeah.
This is not amplitude. Actually, amplitude is the distance between these two. That means from this point to this rest position, this is amplitude. Okay. Amplitude is the length. It's not a point. Okay. It's a length. That's why it's unit in meters. Okay. So if you see amplitude, when I told you the definition of amplitude, it's the distance between the peak and the rest position. This is straight line is what? Rest position. Rest position, which means when particles are resting, when they are not moving at all. Okay. And this peak is the, so the distance between the peak and the rest position, or you can say maximum displacement of a particle. Is this clear?
Yes.
Okay, so basically there are two definitions for amplitude. The first one is the distance between the peak and the rest position. This whole length that you can see, that distance is known as amplitude, or the maximum displacement of the particle. Maximum displacement, which means how far a particle can move. Look, if suppose there is a horse and you tied that horse to a pole, okay, this is horse.
Tell
You tied that
you.
horse with a pole. So what is the maximum displacement? That means what is the farthest distance can this horse travel is the length of that rope. Okay. This is the farthest distance. Beyond that, it's not possible for the horse to move. It's the same. This is the maximum displacement. Beyond that, particles cannot displace, which means if suppose they are vibrating at their own place, this is a particle and it starts vibrating like up and down, so at max it can go to there. Beyond that it can't jump. If we jump, we have certain limits. We can jump up to 1 feet, up to 1.5 feet. It's not possible that on our own place we can jump 8 feet, right? It's beyond our limit. So what is the maximum value up to which we can jump? That is our amplitude. Is this clear?
Yeah.
So how can you define my amplitude?
Amplitude is the length of max displacement of a
or
particle.
it's basically a length, or you can say maximum displacement of a particle from its rest position.
Repeat it, repeat it.
It's a maximum displacement of particle from its rest position.
Repeat it. Repeat it.
Sound max displacement.
Repeat it.
Repeat.
That is how all other things. Repeat it.
Max length or max displacement of amplitude from its rest position.
Yes. So this is the rest position. This is straight line is the rest position, and that peak you can see is the point up to which it can jump. Beyond this, particle can't jump. So this is the maximum displacement, the maximum distance that a particle can travel, or maximum displacement, which means how can it displace itself. So that maximum displacement of particle from rest position is its amplitude. Is this clear?
Yeah.
So define me what's amplitude.
Amplitude is length of max displacement of a particle from its rest position.
Yeah, definition is from here, maximum displacement. Okay, so maximum displacement of particle from its rest position, that is amplitude. Or there's another way, you can say distance between rest position and peak. So these are two definitions. Don't merge them. They are two different definitions. Which means either you can define amplitude like this or like this. But both have the same meaning. So this is the distance between the peak. This is the peak and the rest position. So whatever be the distance between that will give you amplitude. Okay.
Okay.
Now amplitude depends on the loudness. Okay, or you can say basically loudness depends on the amplitude. The wave which has higher amplitude has the higher loudness. Okay, so wave that has higher amplitude has higher loudness. Okay, so wave
Yes.
that has higher amplitude has higher loudness. Is this clear? And the wave which
Yeah.
has lower amplitude then
Wait. So the wave that has lower amplitude is
has lower loudness. Okay,
yes.
which means if wave has higher wave amplitude, higher loudness, lower amplitude, lower loudness. So loudness is totally dependent on the amplitude. Okay.
Okay.
Okay, so it's a vast topic, like it contains the amplitude and the frequency and the pitch. So that will cover in the next class. But you have to revise every point that we have covered in the class, because it's very much important to continue the topic. Okay, so
Yeah.
you should be sound in amplitude, like you should be good in all the topics that we have covered so far. So just read them all once, go through that, and we'll continue that unit in the next class. Okay?
Okay.
Okay then. Thank you.
Bye.
You are currently the only person in this conference.